Hello, this is Rahim, and this is my LinkedIn ID. First of all, Happy New Year 2023. I hope the new year brings peace, joy, prosperity, and love for family to all of us. I'm with you again with another video about 5G, and in this video, first, I'll focus on the 5G RAN split architecture, protocol split, and a centralized RAN. And finally, I'll explain the procedure related to the user inactivity monitoring. Here, we've got the 5G base station GMB in the NG-RAN and the 5G core within the 5G system. To exchange the information, I mean the data user plane and the control plane between the GMB and the 5G core, we need a transport network called Backhaul. According to the 3GPP specification, we can take the functionality of the GMB and separate it into two functional units: CU, Centralized Unit, and DU, Distributed Unit. CU and DU together do the job of the GMB. Two functional units are connected to each other through a transport network called Midhaul. According to the ORAN Alliance, three functional components, CU, DU, and radio unit or remote radio unit, all operating together to do the job of the GMB. Here, we've got a new term for transport network between the DU and the RRU called Fronthaul. For the Fronthaul, we basically need optical transmission. The functional components of the GMB can be geographically separate. In this video, I'm going to focus on the 3GPP specification. I mean splitting the GMB into the GMB CU and the GMB DU. For the centralized RAN, we have a physical separation of the centralized unit and the distributed units. In this example, we have the centralized unit that manages and controls two distributed units. They are physically separate and we require transport network connectivity, for example, tens of kilometers between the CU and the DU. The centralized unit can operate as multiple virtual machines, and it could be actually located in the data center, I mean within the virtualized infrastructure of the 5G core. Therefore, in this special case, the backhaul is very short, so the transport requirement is not actually stringent. The connectivity between the DU and CU is based on the F1 reference point, which is responsible to transport the control plane and the user plane. The centralized unit has also a connectivity to the 5G core via N2 and N3 interfaces for the control plane and the user plane purpose. Here, we've got a GMB, which consists of the centralized unit and two distributed units. According to the 3GPP specification, we can take the functionality of the GMB CU and split it into the control plane part called GMB CU-CP, and the user plane part called GMB CU-UP. We've got the separation of the control plane and the user plane in the centralized unit. Therefore, this approach is more flexible, as control plane and user plane can have expansion separately. From control plane connectivity point of view, we've got F1C between the GMB-DU and the GMB-CU-CP, and F1AP as a protocol is used to exchange the signaling via this interface. We can also see here the centralized unit control plane entity has a connectivity to the access and mobility management function AMF based on N2 and NG application protocol NGAP to control the GMB-CU user plane. The GMB-CU control plane utilizes E1AP as a protocol in E1 interface. In case of user plane connectivity, we have F1U between the GMB-DU and the GMB-CU-UP. The centralized unit user plane entity also has a connectivity to the user plane function UPF based on entry within the 5G core network. The GPRS tunneling protocol V1, version 1 user plane, is used by the entities, the user plane function, GMB-CU user plane and GMB-DU, to exchange the PDUs on both F1 user plane and entry interfaces. In this diagram, there are two CU user plane entities rather than one under the control of the CU control plane entity, and each GMB distributed unit is connected to two CU user plane entities. To sum up, in the split architecture of a GMB, we may have a CU control plane, multiple CU UP entities, and multiple distributed units. One DU is connected to only one CU CP. One CU UP is connected to only one CU CP. And one DU can be connected to multiple CU UPs under the control of the same CU CP. And finally, one CU UP can be connected to multiple DUs under the control of the same CU CP. Here, we've got our GMB that has a connectivity to the AMF and the UPF within the 5G core through N2 and N3 interfaces. To have a fully centralized scenario, we distribute the GMB into the CU control plane, the CU user plane, and the DU functional components. Here we can see the interfaces and the protocols between the different entities. From the protocol stack of view, we should consider which parts of the protocol stack should be processed with which GMB functional components. As you can see from the diagram above, to pass the data between the higher layer and the radio frequency, we've got 8 splitting options. Selection of an option is a prominent task for the implications on the transport network layer. Backhaul, Midhaul, and Fronthaul. The 3GPP selected option 2, splitting between the higher layers, I mean PDCP and RRC, splitting between the CU and the DU with respect to the F1 reference point. For the option 7, splitting between the DU and radio unit or remote radio unit, there are 3 sub-options: 7-1, 7-2, and 7-3. The Oran Alliance is working on option 2 and option 7-2. Here, in the diagram below, we can see splitting of the protocols. The higher layer protocols, RRC, SDAP, and PDCP, are located in the CUCP and CUUP, and the lower layer protocols, RLC, MAC, and physical, are located in the DU. To exchange the information, I mean control plane and user plane, between the CU control plane and the distributed unit, we have 2 protocols: F1 application protocol, F1AP, on F1C, and GPRS tunneling protocol version 1 user plane, GTP-V1-U, on F1U. Here we can see the main functions of F1AP. First of all, interface management, user equipment context management, radio resource message transfer, warning message transmission, SI or system information management, paging procedures, and finally tunnel IDs allocation. The main function of GTP version 1 user plane, we can see here: user data transfer and an R user plane protocol for flow control. To support an R user plane protocol, an extension as a RAM container added to the GTP V1 user plane header. So by this way, there is a possibility to support an R user plane protocol, especially for flow control. To exchange the signaling between CU control plane and CU user plane, we have E1 application protocol over E1. Here we can see the main functions of E1 AP. Interface management, same as F1 AP. Bearer context management, and tunnel IDs allocation to establish the GPRS tunnels per data radio bearer between CUUP and DU. Here, I'm going to explain how the functional components of a GMB are informed during the establishment or modification of a PDU session to monitor the user inactivity. To set up or modification of a PDU session, the Access and Mobility Management function, AMF, sends PDU session resource setup or modification request message to the GMB CU-CP. The GMB CU-CP in turn sends bearer context setup or modification request message using E1 AP protocol to the GMB CU-UP. This message includes activity notification level information element and inactivity timer as well. The level of activity notification could be data radio bearer, PDU session, or UE. The GMB CU-UP then sends back the response to the GMB CU-CP. The GMB CU-CP also can configure the GMB-DU with UE context setup or modification request message, including inactivity monitoring information element. The GMB-DU sends back the response. If the inactivity monitoring response information element is contained in the response message and set to not supported, the GMB-CU-CP understands that the GMB-DU doesn't support UE inactivity monitoring. The RRC reconfiguration message is also sent by the GMB-DU to the device through air interface using RRC protocol, which is not shown here. The PDU sessions and the data radio bearers are established, and then the quality of service flows of the UE are exchanging within the data radio bearers. Here, we consider that the GMB-CU-CP configures only the GMB-CU-UP to monitor the user inactivity. The GMB-CU-UP performs user inactivity monitoring and detects that the user has no activity, I mean UE is inactive in both uplink and downlink direction during the time specified by the inactivity time, for example 10 seconds. The GMB-CU user plane sends bearer context inactivity notification message to the GMB-CU-CP. The centralized unit control plane entity decides whether to send the UE to the RRC inactive state or not. If yes, then the GMB-CU-CP sends bearer context modification request message using E1 AP with suspend indication to the GMB-CU user plane, and then the GMB-CU-UP sends back the response with PDCP status. The GMB-CU-CP sends UE context release command message using F1 AP, including RRC release to the GMB-DU, and the GMB-DU forwards the RRC release message using RRC protocol with suspend configuration to the device via the air interface, and finally the GMB distributed unit sends back the response to the GMB-CU control plane. The device saves the inactive RNTI, I mean RNTI, RAN-based notification area, the timer for RNA update, the DRX cycle for RAN-based paging, and then suspends all the data radio bearers and signaling radio bearers except signaling radio bearer 0, and finally changes its RRC state to the RRC inactive from RRC connected. Thank you for being with me in this video. For more information related to the 5G system, you can also refer to my page in LinkedIn. For more support, please leave your comments under this post. And in the end, please do not forget to subscribe to my YouTube channel.